Hello everyone, and welcome back to lecture. Today is 4-8, right? Yep. Starting to lose track of the days here. 2020. Okay, and today we're going to start chapter 3. In particular, 3.1 is about quadratic functions. Okay. So we've been talking about linear functions. So a linear function takes this form. F of x equals ax plus b. So there's it's linear because it's an order 1 function, meaning that the biggest exponent on your variable x can be is 1. So we're going to talk about quadratic functions. And you may have guessed it, that it's if we can write an arbitrary, just some sort of arbitrary quadratic function in the form ax squared plus bx plus c. So, you can have a, b, and c can be any real number. And if it's quadratic when, you want this coefficient really to be not 0. Okay. So you can, one example, this is infinitely many functions, right? This can represent infinitely many, but if a equals 1, b equals 0, and c equals 0, then we have f of x equals x squared, which we've already had some practice graphing that one, right? And its graph looks like this. So if you have 1, 2, 3, negative 1, negative 2, negative 3. And I'm going to go up by 2s here. 2, 4, 6, 8, 10. So 1 squared is 1, negative 1 squared is 1. 2 squared is 4, negative 2 squared is 4. And 3 squared is 9, along with negative 3 squared is 9. So it kind of makes this arc-like shape, like that. And we call this shape a parabola. Oh, it's A. P-A-R-A. Parabola. Okay, so it turns out that we can make this is the graph for x squared. So now different choices of a, b, and c will affect the way that the graph of the function looks. For example, if we'll go the same. We'll make this a little bit bigger here. If we talk, this is f of x equal x squared. Now what if we have g of x equals negative x squared? Well then, 0 squared is 0, and then if you negate it, it's still 0. But if I take negative 1 and square it, and then negate it, so negative 1 squared is 1, and then if I negate it, you get a negative 1. And ooh, yeah, this is not. Hold on. Let me draw my numbers here before I get carried away. negative 2, negative 4, negative 6, negative 8, and negative 10. Okay. So, I have one right here, right here. Right, if I take 1 squared and negate it, it's negative 1 again. So now if I go to 2, and I square it, 2 squared is 4, and then I have the minus, so it's going to be negative 4. And same over here. And this trend continues. So, if I'm graphing g of x, where a is negative 1, then notice it just flips this positive parabola, or upward opening parabola, into a downward opening parabola. So that's actually a trend. The sine of a, sine meaning positive or negative, determines which way the parabola faces, or opens. That's not another. We might call this in calculus we call this upward facing, upward opening parabola concave up, because it makes it like a cave, and then the cave opens upwards. And then here we call this parabola concave down, because it's a cave going down. Okay, so that's the first part that we need to know about a, or what these values contribute to the shape of the function. Another one is the magnitude of a. So nothing to do with the sign here, but if you make a bigger, so for example, let's graph f of x equals 2x squared, then our graph is going to change a little bit. So 1, 2, 3, 1, 2, 3. Okay, so if I do 2, 4, 6, 8, 10. And I wanted to graph 2x squared. So this is where a equals 2. Notice 0 squared is 0 times 2 is 0. 1 squared is 1. And then if I multiply by 2, it gets mapped to 2. So now if I do 2 squared, it's 4. And then I multiply it by another 2, and that goes to 8. So 3 squared is 9, and then I multiply by 2, and that jumps up to 18, which is way up here somewhere. So I won't graph that. But then let's just compare it to what the graph of plain old x squared looks like. At least on this side. So here we have 2x squared, and here we have x squared. So the dotted line, I don't know if you can see the dotted line very well. The dotted line is just x squared, and this one is 2x squared. So now let's talk about, so if I make the number, or the magnitude bigger, so magnitude has nothing to do with the positive or negative, like the sign of the a, but if I make the magnitude bigger, so if I make it 2 or negative 2, it makes the parabola skinnier. Now if I make it smaller than 1, so if I did g of x here, for for example, is 1/2 x, then let's see what happens. So if I take 1 and I square it and then take it by half, it's actually a half. Now if I do 2, square it, that's 4, and then now I take a half, that's down to 2. And if I do 3, square it, that's 9, and take a half, that's 4 1/2. So right there. And it's actually making it a wider parabola. Okay, so the magnitude of A either shrinks your parabola, makes it skinnier, or makes it wider, depending on if you choose a bigger or smaller number. So the bigger the magnitude, the skinnier the parabola. The smaller the magnitude, the closer the magnitude to 0, the wider the parabola. So it's kind of like a crisscross, like, right? The bigger the magnitude, the smaller or the skinnier it gets. The closer to 0, the wider it gets. So it's like opposite. Okay, so we've kind of talked about the effects that this number A has on the shape of the graph. Okay, so now we're going to talk about the other numbers. We need to learn a new way to write this a parabola. So we're going to learn how to put a function. So we know a parabola in this form: ax squared plus bx plus c. And there's another form. So this is general. There's another one that's standard. Okay, so that's f of x equals a times x minus h squared plus k. Okay, so later in the chapter we'll learn how to take a function like this in general form and transform it into standard form. This is one. Standard form is much easier to if you have a function in standard form, it's much easier to graph, because it turns out that this k and this h is what we call the vertex of our parabola. So we have h comma k is called the, let's see, vertex. So you're probably wondering, well, what is the vertex of the parabola? So the vertex of all of these parabolas that I drew down here is 0, 0, right? It's the origin, because the vertex is where this turning point goes. So it's starting where it's decreasing and then turns to increasing, or increasing and then turns to decreasing. It's a turning point. Every parabola only has one turning point. Okay, so we're going to now look at how we could change, or how h and k change the vertex of the parabola. So you also might want to notice that if a is positive, then we have an upward facing parabola, and our vertex is a minimum. Now, if a is negative, we have a downward facing parabola, and our vertex is a maximum. That's another thing to keep in mind. So let me write that down. If a is positive, then we have an upward facing parabola. Therefore, the vertex is a minimum. And if A is negative, for the same reasoning, we have, or for the same reason, oh, not we have, the vertex is a max because it's downward facing. Okay. And it turns out that the vertex, so the vertex is the point h comma k. So if you think about it, if we have the parabola facing up, then this k value is actually the minimum value of the parabola. And the coordinate h comma k is where that minimum occurs. So if you plug in h, you get the minimum value k, and here it's the opposite. It's the opposite here. H in k would be a max. So it all depends on what value of what sign of a you have. Now let's go in. Let's talk about why h and k are the vertex for a parabola. So if we talk about, so first let's just talk about, again, f of x equals x squared. And now let's talk about f of x or a different function. G of x equals x minus h squared. Okay, so if I draw these two on one coordinate plane here, again, here's 1, 2, 3, 4. So 2, 4, 6, 8. Okay. So remember so if I draw the original function here, just draw some dots real quick. Okay. Right, if I do x minus h, so for example the dot, if I plug in 1, it's actually 1 minus h squared. Okay, so let's actually take a number here for h. Let's just say h is equal to 1. Okay? Then if I take 0 minus 1 squared, that's going to be a negative 1 squared, which is 1. Now if I do 1 minus 1 squared, that's 0 squared, so it's 0. 2 minus 1 squared is 1. 3 minus 1 squared is 2 squared, so it's 4. And then 4 minus 1 squared is 3 squared, so it's 9. So we can already see that this, we can now see why exactly the minus, it's actually, if you want to shift it to the right, you have to subtract the number. So it's the same graph, except shifted to the right. So and that turns out that you can, if you subtract h, you're moving it, and h is positive, you move it to the right. Okay? So that's why h is the x-coordinate of the vertex. Okay, so now I want to introduce one more function. Let's do h of x equals x minus 1, or, yeah, we'll do both at the same time. X minus 1 squared plus 1. So this would be the k, right, in our standard form. A is 1. In this equation, h, A is 1, h is 1, and k is 1. Okay, so if I do that, now I already know that if I wanted to graph this, for example, let's start at 0, we get 0 minus 1 squared is 1, right? That's this part, but then I have to add 1 to it, so it gets moved up to 2. So let's see, this one is x squared, this one is x minus 1 squared. And the one I'm about to draw is h. So now if I go over to 1, it's 0 squared, but then I have to add 1 to it. So it crosses that. If I go to 2, it's 2 minus 1 squared, but I have to add 1 to it. So it goes back up to 2. If I go to 3, it's 2 squared, which is 4, but then I have to add 1 to it, so it goes up to 5. And same here for negative. If I do negative 1, it's negative 1 minus 1, so negative 2 squared, and then adding 1 to it causes it to go to 5. So we can kind of see exactly here negative 2 goes up to 10. Right, so this in 3 would go up to 10. So this is kind of a poorly drawn picture here, but whoop. Right, so unfortunately my picture is pretty poor here, but oh, wait a second. There's a reason. It's because 10 is supposed to be over. It's supposed to be at 3. So let's redraw this. Right, 3 minus 1 is 2. Oh no, 3 is supposed to go to 5, and 4 is supposed to go to 10. So I'm supposed to connect these dots. Got my dots confused here. Right, so we can see that if you can still see this picture. This is this one right here that I'm coloring in here is x squared. Then x minus 1 squared shifts x squared to the right 1. And x minus 1 squared plus 1 shifts it to the right 1 and up 1. Okay, so that's why we see that k is the y coordinate of the vertex. Alrighty. So again, this is the k is the y coordinate, h is the x coordinate of the vertex, and A is, remember, if it's negative or positive, it determines if it's facing concave up or concave down, and it determines how wide or skinny your parabola is. Okay, so now we can maybe move on to an example. So this example asks us to find the standard form of the quadratic function whose vertex is -3, 4, and passes through the point -4, 7. And then it also asks, does f have a max or min? Okay. So remember, we have to take this information here and write it in standard form. So f of x is then a times x minus h squared plus k. So it actually tells us what h and k are, right? It says, I'm sorry, that's not it. Here, the vertex is the coordinate -3, 4. So I already know that this is a times x. I can already start filling in my information here. Plus 4, right? H is -3, so I have to subtract -3 and add 4. Okay, so this is equal to a times x plus 3 squared plus 4. Okay? So let's recopy that down here. So f of x equals a times x plus 3 squared plus 4. So now if we do, now the next piece of, we need to figure out what a is somehow. But they give us one more piece of information that lets us figure that out. It says it also passes through this point -4, 7. So I know that if I put f of -4 in, if I put -4 in for x, then the left-hand side, f of x, f of -4 has to be 7. So, right, so if I do, so 7 equals f of -4, right? That's just from the information that they told us up here in the problem. So a times, now I plug in -4 plus 3 squared plus 4 is equal to 7. So I can eliminate the middleman here. 7 equals a, and simplify a little bit, times -1 squared plus 4. So now I'm going to simplify this, so it's 7 equals a plus 4, right? -1 squared is 1. And now I subtract 4 from both sides, and a is equal to 3. So now over here I can rewrite my equation in standard form. So it's 3 times x plus 3 squared plus 4. Okay, so that answers our, or that satisfies the first part of the equation, right? Because they ask you to find the standard form of the quadratic equation. That its vertex is this, and it passes through the point that. So we've done the first part. Now we have to determine if it has a min or max. So it's a good thing that we found a, and we had to. But since a is positive, that means our graph is concave up. So that means that our vertex is a min. So it has a min of, it has a minimum of positive 4 at x equals -3. Sorry. right? Because that's the vertex of the graph, so that's like the turning point. And because we know that A is positive, we know that it can't get any smaller than the vertex is. Okay. Now we're going to move on to the next example. Okay, so we're going to talk about now sketching the graph of negative 3x plus 2 squared plus 12. Okay, so remember we have some key pieces of information that we have to look for here. So we've got A is negative 3, so already this tells us how wide our parabola is going to be and that it's going to be concave down. And we can rewrite this, so so this is negative 3 times x minus negative 2. You want to get the minus in there because it's x minus h plus 12 equals f of x. Okay, so this tells us that the vertex is going to be at the point negative 2, comma 12. Okay, another thing you want to do when, so we already know that, right, so we already know that the point, whoops, I should have drawn this over here. So starting with this information, if I have negative 2, 2, 4, 6, 8, 10, 12, I know that the vertex is going to be here at the point negative 2, comma 12. Because that's what h and k are. And I also know that I don't need to draw my coordinate plane any higher than 12. Since it's going to be a downward facing parabola, since our a value here is negative. Okay, so we need to figure out some other points that this parabola passes through, and a good one to figure out are the x-intercepts. So remember, we talked about that last section. So the x-intercepts are so this is from yesterday's lesson. But the x-intercept is when you set y, or f of x, equal to 0, because you want to see where x, the function crosses the x-axis, which is precisely the line y equals 0. Okay, so we're going to set 0 equal to negative 3x plus 2 squared plus 12 to find the x-intercepts. So now we did this in the last section, but we'll do it again. So we solve for x to find the x-intercept. So 0 equals, so we got to factor this out, so it's negative 3 times x plus 2, and if you don't remember that x plus 2 formula, it's okay, we can just FOIL. Alright, so this is equal to negative 3 times x squared plus 2x plus another 2x, so plus 4x, and then now we have finally plus 4, and then plus 12. Okay, so 0. So instead of multiplying this 3 out, I'm just going to factor out a negative 3 from this 12 too, so I don't have to deal with that. So this is 0 equals, I mean, you can do it that way certainly too, and then divide everything by negative 3. That's also fine. So this is equal to negative 3 times x squared plus 4x plus 4. and then I'm going to write 12 as plus 12 as minus 3 times 4. So I can pull this negative 3 out. I can divide now both sides by negative 3. Right, so this is still 0. And since there's a negative 3 in both terms, this cancels. So now it's x squared plus 4x plus 4 plus 4. Okay, so this is 0 equals x squared plus 4x plus 8. Okay, so factoring now, this is solving this equation is something we did already too. So we need two numbers, since this is an a is 1, or since the coefficient in front of the x squared is 1, we need two numbers that add up to, or multiply to 8, positive 8, and add up to 4. So so let's see, how can we find that? Well, let's see, did I mess up here? Oh, yeah, I did. I made a slight mistake. So, negative 3 times 4 is not positive 12, it's actually negative 12. So, I need to write this as negative 3 times negative 4, because I want to get the positive 12 back. Right, so this is now a negative 4, and this is a 0. Okay, so this one is actually easier to solve because I can just factor out an x. And now we have x times x plus 4 equals 0. So either x equals 0 or x plus 4 equals 0. Or this one also says x equals negative 4. So these x equals, the x-intercepts are x equals 0 and x equals negative 4. So, again, another important point to find. So from this information, first, before I go into the next thing, we know that 0, comma, right? The x-intercept just happens to be 0 here, but x-intercepts are where the y-coordinate equals 0. So we know that the point 0, comma 0 is on there, and negative 4, comma 0 are on our parabola. So if we go back to our parabola picture, we can add on negative 3, negative 4. We can add these 2 points onto our parabola. Okay? And it turns out that your parabola, right, so we have this thing called the axis of symmetry. So your vertex is always going to be in between the two x coordinates when you have a parabola. So our parabola is going to kind of go like this. All right. So in this example, where we can be done, well, we might as well be done, but you should also find the y-intercept, and in this case, it's actually the same as the x-intercept, right? The y-intercept is when x equals 0, but we already found that the point 0, 0 is on our graph. But anyway, remember the y-intercept is when you want to see what f of 0 is, right? So f of 0 equals negative 3 times 0 plus 2 squared plus 12. Okay, so that's equal to negative 3 times 4 plus 12, which is equal to negative 12 plus 12. So it's equal to 0. So again, this means that when y is equal to 0, x is equal to 0. And it's unexciting in this example because x-intercept, the y-intercept is the same as one of the x-intercepts. So when you have a parabola, you're always going to have one y-intercept, and you're always going to have, you're either going to have two x-intercepts, one x-intercept, or zero x-intercepts. Right? You could have the three different situations here are, if you have two x-intercepts, it might look like this, or it might look like this, right? If you have one x-intercept, well, think about just the simple x squared parabola. That only touches the x, or the y-axis. Sorry, it only touches the x-axis once at 0. Then the other one could be, what if your parabola looks like this, or if it looks like this, then it doesn't even cross the x-axis at all. So you will always have a y-intercept, because in every one of these situations, it's always going to go on forever and at some point cross the y-axis. And here, this one would cross down here, this one crosses right here, this one crosses it here too. Okay? So those are some things to keep in mind when graphing a parabola. So again, the final look at our parabola, if the y-intercept happened to be a different point than the x-intercept, which is just a coincidence in this problem, then we could add another point onto our graph. All right. So now we're going to talk about taking a general form to standard form. Okay, so f of x equals ax squared plus bx plus c. And this one, remember, is f of x equals a times x minus h squared plus k. So we want to be able to, if someone gives us an equation here, we want to be able to spit it back out in standard form. Because we can always, going from standard form to general form is a bit easier, because all you have to do is just multiply, distribute out this squared, FOIL it, and then you simplify, like we did when solving for some of those x-intercepts. But because here, I'll just do it real quick. So this one is going to be a times x squared minus 2hx and plus h squared plus k. Okay, so then so this is going to be ax squared minus 2ahx plus ah squared plus k, right? All I did here was just distribute out that a. So now this is equal to ax squared minus 2ahx plus, now let me put these in parentheses since they're all constants here. There's no variables in this term. So this term, a is still a, right? That didn't change. But now b in general form is equal to negative 2ah in standard form, because that's the coefficient in front of the x. And c is equal to, c from general form is equal to ah squared plus k. Okay, but we want to be able to go from, this is going from standard form to general form. We want to now go from general form to standard form, and it uses a trick that we've already actually learned. So we're going to use the trick completing the square. Okay, so So let's say I had x squared minus 4x plus 3. Well then, and I wanted to write it in standard form. Okay, so then what I would do is you first want to maybe you can group this x squared minus, or just here actually. You look at x squared minus 4x. You want to look at the two terms with the x's in it. And you ask yourself, well, what do I need to add here to make this a perfect square, or something that you can write as x minus some number, let's call it h, right? Hint, hint, squared. So remember, the way you do that is if I wanted to complete the square here, I look at this coefficient here, and I say, well, I'm gonna first -4 divided by 2, because I want to see, I need two numbers that when added together they equal -4. So if I divide that -4 by 2, it's going to give me -2. If I add -2 to -2, it's going to give me -4. Okay. Right. So but then I need to square it, because -2 times itself will be what we want to add on. Right? We did discuss this. I'm just doing it back when we learned how to complete the square. But you always look at the coefficient in front of the x. You take it, divide it by 2, and then you square it. So that's going to be +4. So +4 is what I'm going to add on, and then also subtract to this equation here. So now you get f of x is equal to x squared minus 4x plus 4. So I want the +4 to go, since I got a +4 here, I want that to go on the end of my first two terms, so I can have a perfect square. And then if I add 4 to this equation, I also have to subtract 4, right? And I could, since I'm only adding and subtracting here, I can take these parentheses off, but I just added them artificially just to emphasize that we're gonna factor this. Okay, and then we still have this leftover +3. So now we're going to factor this because it's a perfect square. So again, this works out because we made it work out. Two numbers that add up to 4, or multiply to 4 and add up to -4. So x minus 2 and x minus 2 do the job. So that's factoring this quadratic right here. And now I still have this -4 plus 3 left over. So this is equal to x minus 2 squared minus 1. And what do you know? Now we have f of x in standard form, when we started with f of x in general form. So this tells us that a is equal to 1, so we're going to have a upward facing parabola centered at -2 and, centered at +2, and the x-coordinate is +2 and the y-coordinate is -1. So that is the technique for taking a parabola in general form and setting it to standard form. Okay, so if we wanted to do it like this, I'm now going to do it for a general function. So now, but doing this example first, we'll kind of see what the process is. So if I'm given a function f of x equals ax squared plus bx plus c, and I want to write it in standard form. So first thing I'm going to do is artificially, I'm going to write this as ax squared, and I'm going to multiply here by 1 in disguise. So it's going to be a times b x, but if I multiply this term by a, I also have to divide it by a, right? This fraction here can also be written as ax squared plus, now I'm just going to do a times b over a times x, right? Because this is a over 1 and this is x over 1, and it's just multiplying fractions. These two things are the same, right? If you want to multiply fractions, you multiply all the numerators together, a, b, and x, and all the denominators, 1, a, and 1. Okay, so this is the one that I want to work with here, though, so then we have plus c. So let's just recopy that line down. So we have f of x equals ax squared plus a times b over a x plus c. So in our example, this is actually something we didn't have to do because a was 1. So if your a is something other than 1, this is something you have to do. Okay. So now what we do is we're going to take, out of these two first terms, we're going to factor out an a. So it's f of x equals, because there's an a in both of them, because we rigged it that way. So now we have a times x squared plus b divided by a x, and then also plus c. Alrighty. So now we've got a we have to use that completing the square process. So again, we want to look at this term here, right? Look at x hat. Looks like a t, like the constant times t. So at x squared plus b over a x. Right, just like in our example before, we looked at x squared minus 4x, right? We're now looking at x squared minus 4 over 1, because a is 1x. And we have to complete the square. So what we need to do is we need to take, remember we need to take the coefficient in front of the x, b divided by a divided by 2, and then square it. So this can be rewritten, right? 2 is really 2 divided by 1, and when we're taking a fraction and dividing it by another fraction, it's the same thing as multiplying it by the reciprocal. So this is the same thing as b over 2 times a squared. Right? And then when we're squaring a fraction, we can kind of distribute that exponent. So it's the same as b squared over 2a squared, which is the same thing as b squared divided by 4a squared, right? And when we're multiplying two numbers and they have the same exponent, it's not an equals, that is a 2, let's see, 2 squared. We can distribute it to both numbers there. Okay, so now we have to add and subtract b squared over 4a squared to our quadratic term here. So now we're going to do x squared plus so actually I'm going to write, so we were just looking at this term here, but we were really trying to complete the square up here. So it's f of x equals a times x squared plus b divided by ax plus b squared over 4a squared. So if I add it, I have to subtract it, right? Because you can only add 0 and not change the function. B squared over 4a squared. And then also I'm still left over with that plus c. Okay, so now that we've got that, we can perfectly square our term here. So just like we figured out that we needed to add and subtract 4, right? 4 here, if in our first example, b is -4 and a is 1. So b squared is 16, -4 squared is 16, and then I'm dividing it by 4 times 1, which is 4. So I add and subtract 4. Right? This is just the more general case. Okay. So this one is f of x equals, now if I factor this quadratic term here, I need two numbers that multiply to b squared over 4a squared and add up to b squared, or b over a. Right, so this is x plus, so if I do b over 2a, that works, because, let me write it this way first, x plus b over 2a minus b squared over 4a squared plus c. So now if I multiply these two, right, if I multiply these two for the last term, you get the numerators multiplied by each other and then the denominators multiplied by each other. So it's b times b, which is b squared, and 2 times 2, which is 4, right? If you're 2a times 2a is equal to 4a squared. So it works out perfectly. Right? And then if for the middle term here, if I have, x times x gives us the x squared. Now x times b over 2a is x times b over 2a, right? That's for the outers. And then if I do the inners, it's again plus, so FOIL is first, so that's x squared, and then O is outers, so x times b over 2a, and then I have another x times b over 2a, and then last but not least, we have our b squared over 4a squared, which we already talked about. Right, so now if I add, I could write this as x squared plus 1/2 b over a x plus 1/2 b over a x plus b squared over 4a squared. And 1/2 of a number plus another half of a number is just that b minus a, x. It's just 1. So this is equal to x squared plus b over ax plus b squared over 4a squared. So basically I just gave you the factorization here and told you if you FOIL this out, you get right back to where we started. So it works. Okay? So bottom line is now we have f of x equal to a times x plus b over 2a minus b squared over 4a squared plus c. Okay, so look, so we've started with this general form quadratic and did a bunch of algebra, did our completing the square all the way down to here, and we've got a formula that's now in standard form. So look at, so if I write this as a times x minus negative b over 2a minus b squared over 4a squared plus c, this portion is k from standard form, and this term right here is h. So we can either go through and actually complete the square every time, or you can just know that we did it once for all of the quadratics and remember these formulas, that h is going to be negative b over 2a and k is going to be negative b squared over 4a squared plus c. Okay, so find the x coordinate h. So now if someone gives you a general form quadratic function, you can write it in standard form just by knowing these formulas. Or you can complete the square. It's not a big deal. So this brings us to our next example. So it wants you to sketch the graph f of x equals 2x squared plus 8x minus 10. So again, just to remind you what we just did, h is equal to, here, let me explain. So before they asked us to graph a quadratic that's already in standard form, but now they ask us to graph one that's in general form. So the first thing you should do, unless you actually want to just go through and plot a bunch of points, is to just write it in standard form. So how do we do that? Well, remember what we just did is h was equal to negative b over 2a, and k was negative b squared over 4a squared plus c, or that's equal to c minus b squared over 4a squared. So we first have to identify that a is equal to 2, b is equal to 8, positive 8, and c is equal to negative 10. So now I'm going to figure out what h and k are. So h from our formula is negative 8, negative b, divided by 2 times 2, 2a. And k is equal to c, which is negative 10 minus 8 squared over 4 times 2 squared. So this one, h is equal to negative 8 over 4, which is negative 2, and k is equal to negative 10 minus 64 divided by 4 times 4, which is negative 10 minus 64 over 16. And 16 times 2 is 32. 16 times 3 is 48. And 16 times 4 is 64. So 64 divided by 16 is 4. So this is equal to negative 10 minus 4. Okay. One moment here. Alright, so I realized I have made a mistake. So we're going to put this example on pause for a second. And we're going to go back to this formulation here. So it turns out here we're not quite done. This is not exactly wait a second. Okay, so the error occurred in the step here. We figured out what we need to add and subtract. B squared divided by 4a squared. What we need to add and subtract when completing the square. So it was b squared minus 4a squared. The problem is we need to add and subtract that from inside here. Okay, so this term here, I'm not actually adding and subtracting. If I would have left the parenthesis where it was, I'd be adding a times b squared over 4a squared and only subtracting b squared minus 4a squared. So see the difference? If I left the parenthesis here, I'd have to eventually distribute out the a to this term, and it would be a times b squared over 4a squared, and I only did subtract b squared over 4a squared. So there was no a in this term. So that's a problem. So we need to, the fix is just move the parenthesis out here. So then if I do that, then I can rewrite this term here. Just grab another sheet so I can fix this. I would rewrite this term as I would have to write a times x squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared plus c. That's what I wanted instead of what I wrote down earlier. And I would rewrite this as just distribute out the a to the last term and kick it out of the parentheses. So it's a times x squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared. Whoops, so I just copied that. So it's in the parenthesis, and then since I distributed it, it's minus a b squared over 4a squared plus c. Okay, so now so now the same steps for factoring this still happen. So this is a times x plus b over 2a squared. But the difference is here, now one of these a's cancels with an a squared, or one of the a's down here. So it's minus b squared over 4a instead of a squared plus c. So this is k. So k before was, the incorrect k was b squared over 4a squared. It should be b squared over 4a plus c rather than b squared over 4a squared plus c. Okay, so that's my fault. Messed up there. So h. So the formula for h, or well, if I go back to the example we were working on, I would now change this. This formula changes to b squared over c minus b squared over 4a. Okay, so that's where the formula changes. These are correct now. Okay. Alrighty. So then this now takes the square off of this, and this becomes a 2. So this becomes an 8, and this becomes 64 divided by 8 is 8. So this is equal to negative 18. Alrighty. So we now know h is equal to negative 2 and k is equal to negative 18. So, right, so our vertex is negative 2 and negative 18. So if we want to graph this function, keep in mind here, the function is 2x squared plus 8x minus 10. We also should find x-intercepts and y-intercepts. Okay, so this one is x-intercepts are when you set the left-hand side equal to 0. So 2x squared plus 8x minus 10. And so everything has a 2 in it, so I'm going to divide both sides by 2. So we get 0 equals x squared plus 4x minus 5. And so now this is a factorable. So we need two numbers that multiply to -5 and add up to positive 4. So I would do plus 5 and x minus 1. Okay. And now, so we have the x-intercept, so the y-intercept, remember, is when we just do f of 0. So this is equal to 2 times 0 squared plus 8 times 0 minus 10, which is equal to minus 10. So this one tells us that the x-intercepts are, oops, so this one would be x equals -5, and this one is x equals positive 1. So the x-intercepts are the points 1, 0 and -5, 0. Right? Those are the points where the y-coordinate is equal to 0. This one, the y-intercept, is where x is equal to 0. So these 4 points are on the graph, including this vertex. Okay, so now if I want to make the graph, I can make the graph. So we need to go all the way down to -18. And right, so the last bit of information is that, remember, A was positive, so we're going to have an upward facing parabola. So we need to go down to the vertex 18. So if we have -1, -2, -3, -4, and -5, and a 1, 2, 3, then our vertex is, let's see, this is going to take a little bit, 2, 4, 6, 8, 10, 12, 14, 16, 18, and these are all negative. Okay, so our vertex is here. -2, -18. Hi, kitty cat. And then we go up to our x. First x-intercept is -5, 0. Second intercept is 1, 0. So our axis of symmetry is right here. And our y-intercept is this point. So